In this case, what I'm going to be doing is building a sentence up in this portion of the screen out of words and phrases that I select from the menus down below. For example, the sentence starts with show, show the average number of days of sun in, and now I'll choose a city, in El Paso. Now I've got a complete sentence and I can ask for the answer. Show the average number of days of sun in El Paso, 319 days. Now,
this is your Tech News Briefing for Wednesday, December 7th. I'm Zoe Thomas for The Wall Street Journal. Today, we are talking about Chat-GPT, a state-of-the-art conversational AI model developed by OpenAI. Chat-GPT is capable of engaging in human-like conversations, providing answers to questions, and even generating original content. That little introduction was written by Chat-GPT itself, after just a short prompt from me. The artificial intelligence chatbot is suddenly everywhere, reaching 1 million users on Monday, just a week after it was released, according to its maker, OpenAI.
What exactly is artificial intelligence, and does it even exist? We'll get the answers to these questions as we take a look at artificial intelligence on this edition of the Computer Chronicles.
These things, what are the kinds of things that you'd say AI can add to?
Well, what it
products?
can add, well, first you have to understand what it is. It's really methods for programming using symbols and describing their interrelationships, and then being able to reason about them to reach some kind of conclusions or enhance some existing type of application. What we're going to see in the next few years is a continued growth in the utility and intelligence, if I can use the word loosely.
Making programs a little bit easier to use and a little more intelligent.
A little more intelligent. We're going to begin to see out of Lotus, certainly, and other companies, programs to begin to know more about their intended use, and that can help the user by interpreting the user's intentions as opposed to executing the user's commands.
Okay, Harry, that's a perfect introduction to what you've got.
Give us an example of it.
You've got a natural language system, one part of AI first, and show us what that is.
that's right. What we have is a way to ask questions of the computer in English so that the user doesn't have to learn an arcane computer language before he gets started. In this case, what I'm going to be doing is building a sentence up in this portion of the screen out of words and phrases that I select from the menus down below. For example, the sentence starts with show, show the average number of days of sun in, and now I'll choose a city, in El Paso. Now I've got a complete sentence and I can ask for the answer. Show the average number of days of sun in El Paso, 319 days. Now, the benefit of this is that somebody who doesn't know anything about the kind of database that we're interfacing to or anything about how to command that database can come up and immediately see what kind of information is in there and can immediately find out how to get the information out.
Harry, can you actually do the inverse of this process and type the sentence in immediately, or is it something you select off the menu and construct the sentence?
You select off the menu and construct the sentence. I had been doing research in the area of natural language processing, which is the act of typing in the sentences and so on, for quite a few years before I came up with this approach. The benefit of this approach is that 100% of the queries that the user puts in will be understood because the user finds out what kind of sentences he can put together, what kind of things the system is going to understand.
How would you compare this with, say, with products that say where you actually type sentences in and there's algorithms and heuristics that actually go in there and try and figure out what the sentence is? Is this the same kind of a product or is this a different kind of thing?
Yeah, what we did was if you take away the menus, behind the menus lies the exact same technology that's in the conventional natural language systems. All we've done, there are limitations to any natural language understanding system, and all we've done is to reveal to the user what the extent of that system is and what the limitations are.
So if one were to peel this layer off, you could actually start typing sentences and it would understand that. So the underlying algorithms are like that then.
That's right.
I'd like to ask you now, we're trying to get a handle on this definitional problem. Now, what we just saw, would you call that artificial intelligence?
I would say that that's really in the category of a tool, and what you've seen is an application of that tool to querying a database in particular. That's all I would say.
So who knows?
I really don't think it's accurate to say one thing is or is not an AI product. AI is not something special that you add to an existing program. It's an approach to programming and creating programs that are flexible or useful or solve problems which previously might have required some kind of human intelligence or attention.
Well, it's certainly the case that there is a gray area there between what we could call a user interface and something that really understands the sentence.
Yes.
And that's,
I think I would define AI a little bit differently from what we've heard. AI, when it started out in the early 50s, was really a set of problems. How can we make computers reason? How can we enable them so we can talk to them or let them see? Or other problems like that that we recognize in humans that we do, and we associate that with intelligence. How can we take that same capability and put it into our artifacts, into our computers? Well, it's this range of problems that make up what is AI. We've developed a whole collection of technologies to address those problems. The natural language that I've demonstrated is one of the approaches. There are many, but one of the approaches to that sort of problem.
Okay, show us the expert system you have
is
here
another.
now.
Now, what we have here is a technique for decision-making and making of judgments, in this particular case, for diagnosing problems with your car. The system is asking, what is the problem? Well, my car is making a strange noise, so I select that choice. Does the noise change between standing still and driving? Yes, it does. Does the noise change on a different type of road? Well, no, in this particular case, the road doesn't make any difference. Is the noise a squeal? Yes, it's a squeal. Is the noise most obvious when starting the car? No, for my problem, that's not the case. Is the noise most obvious when braking to a stop? Yes, it is. Well, the system has come to a diagnosis of the problem. And the diagnosis is that the brakes may be glazed, the rotors or pads of disc brakes, or the linings of drum brakes should be inspected for glazing or dirt.
Okay. Now here in this particular case, this is again for clarification, how does this differ from, say, just a strict yes or no decision-making process, getting you down to the point where that someone has literally put in all the yes or no answers, get to the final point? Are there judgments and valuations put on each one of these
Now, the real difference that comes through expert systems as opposed to other programming techniques is what Jerry was talking about earlier, is the way that the system is programmed. In this particular case, the case of building rule-based expert systems, as they're called, the knowledge that goes into it is in the form of a collection of rules, the little pieces of information that chained together can build up to make decisions.
And these rules come from where?
They come from an expert, somebody who knows how to fix cars.
Now, behind this, is there a generalized tool that, say, could be applied to not only automobiles, but, say, fixing refrigerators?
Absolutely. What's behind this is a tool that can take these rules, these little pieces of information, for whatever context you're in, and tie them together to make a decision or make a judgment.
Now, is this general enough to be applied to virtually anything? Any kind of a decision-making?
Well, virtually anything
in the sense
is a
that
big
if
field.
you had an expert that would come and write rules about literally anything an expert write rules about, could this system apply to that?
The fact is that expert systems are being applied to a very broad range of applications. For example, there was one developed at Johns Hopkins for diagnosing poisoning situations that you can have on a hotline. When somebody calls in, you find out what to do about.
We've seen that here. In fact, Jerry, we have just about a minute left. You mentioned that at Lotus you are working on some ways to use AI, whatever it is, in application software. Give us a clue as to what areas we can see coming up.
Well, I think what we're going to see is improvements really in three ways. The first is new classes of applications and products. And of course, I'm not about to pre-announce anything, so I have to be somewhat circumspect about talking about that. But we're looking into areas of flexible databases, just certain kinds of decision support systems, programs that will help you to keep organized, help you to carry through rational processes that typically are easier for machines than for people. Reasoning aids.
Right. Now, going back to the natural language aspect of artificial intelligence, one of the leaders in the country is Stanford University, Professor Terry Winograd, and our reporter Wendy Woods went to Stanford to talk to Professor Winograd.
Professor Terry Winograd of Stanford is today working on two projects, one programming, one political. The first is a natural language for programmers, which enables them to use simple English words referenced to the kind of work the software will be doing.
the whole quest has been to move away from having people give very specific details of what the machine should do to putting things more in the terms that make sense to them in their world. If I'm doing payroll program, I want to think about people and payrolls and money. I don't want to think about disk files and records and who knows what's in the computer.
His second project concerns funding for AI research. He's worried that too many of his colleagues are being lured into lucrative Defense Department contracts, detracting them from basic research into AI.
The Star Wars in particular has a very specialized spectrum, and I think it's going to distort research to focus much of the money, huge amounts of money, on those particular technologies which are for, as I said, very fast, radiation-hard kinds of computing.
Currently, up to 50% of computer science research is supported by military grants, and only a fraction of computer scientists have refused them.
Professor Winograd and dozens of other computer science professors are circulating petitions asking that their colleagues not accept Department of Defense Star Wars funding. Their belief is that it will drain money from AI projects with practical applications, increasingly through the rest of the century. For the Computer Chronicles, I'm Wendy Woods.
Joining us now in the studio are Gary Hendricks, Vice President of Advanced Technology at Symantec, and next to Gary is Dr. Hubert Dreyfus, a professor at UC Berkeley, the author of What Computers Can't Do, The Limits of AI, and a new book entitled Mind Over Machine.
Hubert, I'd like to start with you and say, let's just say, what are the kind of fallouts you're going to see from AI in terms of useful products for people?
Well, it's not really my field. I'm a philosopher. I'm more interested in the limits of AI.
We'll start at the bottom end.
Okay. Well, I don't know about the fallouts. I'm on this show to find out about the fallouts.
Okay.
What I want to say is that you can't use what's called symbolic descriptions and rules and inferences to make computers intelligent like we are, which doesn't mean that you can't find many uses for them. And for that, that's not my job.
Now, what's the reason that you can't do that?
Well, the reason, I think, is that people begin by using rules when they're learning some new skill, but as they get really good at it and develop a lot of experience, they recognize the situation they're in as similar to one that they've already been in, and they just do what worked before. And therefore, they don't need to analyze the situation. In fact, analysis is really for beginners. Intuition is for experts.
So that's where the difference is, in intuition that comes into it.
Gary, do you disagree with that?
Well, I think there's some truth in it, to be sure. But we have to start with the premise of what's the enterprise that we're at. Now, one enterprise is the scientific one of trying to push AI to the limits to find out just exactly what a machine is, in fact, capable of doing. Another is to take the body of techniques that have been developed so far and try to put those into useful products. And here we're paired up a philosopher and a very pragmatic person. My own view is that we haven't nearly reached the limits of what we can do, and what we need to do is take those things that we have discovered, put them into machines, and make practical tools for people.
Gary, there's been a lot of activity around Q&A. Can you show us that product?
Oh, I'd be really pleased to. What we have here is the top screen of the intelligent assistant. Unlike the
I might have slipped through, by the way. This is called Q&A.
Q&A, that's right.
What we're taking a look at. Go ahead.
Okay.
The system that you saw from Texas Instruments a minute ago had you make selections from a menu of choices. That gave a great deal of control over what could be said. Here we just let people type in questions pretty much the way that they would like, and we go through, you can see the flickering cursor, to analyze them. After they've been analyzed, we understand what the user wanted to do. We then automatically write a program to produce this result by looking at the database and formatting the data. And just to make sure that we're in sync, another program looks at that program and translates it back into English.
Specifically, what's it doing?
So we had here, I want to find the forms for salespeople who earn more than $15,000 and display them for me. And it translates this into select and view the forms on which the department is sales and the salary is greater than $15,000. And after I see that these two are in fact in agreement, I press the button and away we go to the database to pull up the first form which displays information. Now we can step through these one at a time or zoom in on a whole set of them. Having pulled these up off the disk, I can go down and pick a particular one and then zoom back in on that one as an individual. Now the interesting thing about natural language is the ability to ask follow-up questions, particularly using pronouns. So the next question that I'm going to ask here is, Now I want to see a report that shows the address and salaries of these people. The "these people" refers back to those sales folks who are earning more than $15,000.
Let's stop for just a second now. Do you feel like an untrained individual can come here and just type any sentence?
Well, you certainly can't ask what's interesting on TV tonight and expect it to work.
Let's say it's around the database. I mean, is there going to be a dialogue going back and forth about, well, I don't understand this, and please tell me about this, or because obviously if you type the right kinds of sentences, they can be parsed properly. So what is your feeling? What's your experience so far with that?
We're certainly not able to parse 100% of the sentences that are typed. But if your purpose is not to break the system or to push the limits of AI, but rather to get a job done, and you sort of cooperate with the system, then the probability is very high.
Is it a training process that goes both ways in the sense?
It is.
You've got some examples,
you teach the system, and the system teaches you. And we'll see that in just a moment. Maybe we could finish this one just quickly. We asked that these be sorted by state, and we also wanted to see the totals and averages. It translates that into the internal query. We go off to the database and pull the information up. And now into the state of California, we get the employees there with their addresses, their salaries, the total for salary, the average for salary, and then moving over spreadsheet fashion, we get the same thing for the field that was calculated on the fly of salary plus bonus. And then also spreadsheet style, you can walk down through the whole report and finally get the grand totals and the grand averages.
Okay, show us the teaching part here, Gary.
All right, if we take another sentence, that doesn't have a word in it that's known, that has a word in it that's not known, it'll stop. In fact, I've asked if an employee has a salary between the average Harvard man's and John's, do something, and it doesn't know the word man. At this point, I have a number of options. One of them is to teach the word, so I'll select teach. I'll select to teach it as a synonym, and now I'll say that man is a synonym for male, at least in this database. And having done that, we restart the parse process, and this new definition has been placed in the lexicon, so it'll be there next time we want to ask a question using the word man. The question itself is rather interesting. If an employee has a salary between the average Harvard man's and John's, let me see his evaluation and review comments, because in an ordinary database management system, you'd have to ask 3 questions to do this. First, you'd have to find the salary of the average Harvard man, then you'd have to find John's salary, and finally, do yet a third pass after writing down these intermediate numbers. This does it all for you.
It also has a problem with John here. Apparently.
Yes, it does, because there are 2 Johns in the database. It tells us about that. Now we can press a button and it pulls up a little display. If we know which John it is by name, we can just select it off. If we don't know, we can zoom in on the forms for this. This one makes 32,000. The other guy makes 100. That's the one that I wanted. I'll select that John, and now we'll make the third pass through the database, and here's the result based on that computation. So there's an important
difference between this and just a keyword type of a search. You're actually trying to take the sentence apart and figure out what the pieces are.
It's just like what you do in about 7th grade in part.
What will 1987 be the year of? Remember this time last year when all the writers were saying that 1986 would be the year of artificial intelligence? Well, it didn't turn out that way. AI products have generally been a disappointment, and the stock prices of AI companies fell to a 3-year low at the end of '86, down an average of 26% from a year ago. One big factor in the future of artificial intelligence applications will be the role of the Defense Department, which up until now has been a major supporter of AI research, especially to support Star Wars or SDI.
Out of time. What are the limits of artificial intelligence, and is intelligence uniquely human? We asked our commentator George Morrow for his thoughts.
Artificial intelligence. Such an overly ambitious name for any discipline. One day, when we're all more computer literate, this expression will take its proper place with other classic contradictions such as postal service or military intelligence. How could such names such as expert systems or artificial intelligence ever have been coined in the first place? Well, my theory is that in the late 50s, when university-based computer research was largely funded by the military, these names were invented to impress the granting agencies. As often as not, this type of research had little, if any, connection with reality, and the more ambitious the sound of the project, the better chance it had to be funded. Now, much of today's AI-type software is quite novel and very useful, but none of these products will be able to live up to the image that the term artificial intelligence invokes. Why not, as Dr. Dreyfus suggests, call an expert system a competent system? On the other hand, if a vendor insists that one of his products is intelligent, we should insist that the product take a standard IQ test and that the score be affixed to the package. That's how I see it. I'm George Morrow.